Hello, so we are wrapping up our notes on binomial distribution. We just have two more examples to do, which are pretty easy. We're just going to learn about a different button today that we're going to use on our calculator. Still binomial distribution, but now we're talking about a cumulative binomial distribution function. And so, whereas in the past what we've been saying, the probability that the outcome that you get is one value. What's the probability that you have success 3 out of the 10 times. And in the past, what we've been doing for things of like at most 3, we said, okay, well, that's the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. And then we had to add each of those individual probabilities together that we got from our binomial distribution on our calculator. There's actually a button on your calculator where you don't have to add them. You can just plug these values into your calculator and it automatically adds all those probabilities together. So this is the binomial CDF. You'll see it right below the PDF. So before it was probability distribution function, now this is cumulative distribution function. And it's just saying, okay, at most, at least, those types of wording, we'll be using this. So let's talk about it. In a large shipment of light bulbs, 4% of the bulbs are defective. That's a success rate. 4% is represented as 0.04. Success, even though technically we're talking about defective. In a sample of 20 randomly selected light bulbs, so our sample size is going to be 20. What is the probability that there are at most 3 defective light bulbs? The wording on all of these problems is the trickiest part. And so I know that from reading a lot of what you guys have to say about our first probability unit is that the language is what really trips you up a lot. And so I would recommend plugging in values really quickly and seeing like, okay, wait, what are we looking at here? So if it says at most 3 defective light bulbs, you can think for a second, step back and say, okay, does 2 satisfy this situation? Yes, that would satisfy the situation because at most means you can have less than. So 2 would be fine, 4 would be not. So we're talking about less than or equal to 3. So what is the probability that our outcome is less than or equal to 3? And before that was the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. And now we can just use our binomial CDF function and plug these values in. And we're going to go between 0 and 3. So we go to menu, and we still go to probability, we still want distributions, and if we scroll down right below binomial PDF is binomial CDF. So that's just B. So whereas before we were doing 5-5A, now we would do 5-5B. If you have a TI-84, I'm pretty sure it's like right below it or right around, so I think you can probably find it without having to do too much searching. Number of trials, so still the same type of thing. We have 20 numbers of trials. Probability of success, in this case, we're saying the 3 defective light bulbs, so we're looking for the probability of it being defective, which is 0.04. Your lower bound, it automatically plugs in 0 because it assumes that you're going to be doing that. It's not always the case. We'll see about it in our next problem. But in this case, it's true. Our lower bound is 0. We're starting with the probability of 0 and going all the way up to the probability of 3. You can go ahead and press enter on that guy, and it just added all of those probabilities together. And to 3 significant figures, that would be 0.993. And that's it. That's all we're learning about today. Just how to use this and practicing. Okay, so part B, there are at least 6 defective light bulbs. At least 6 means 6 would satisfy, 7 would satisfy, 8, 9, 10, all the way to 20. So this is the probability that x is greater than or equal to 6. So probability of 6 plus the probability of 7 plus all the way up to the probability of 20. But since it's a range, it's cumulative, we know that we could just use our cumulative distribution function. So I go back again. Oops. We want menu 5-5B now. Number of trials, 20 still. And probability of success, we're talking about probability of defective, so we use the probability of it being defective, 0.04. Now our lower bound is not 0, we're starting at 6 and then going all the way to 20. E -5, remember that's our calculator's way of saying this is scientific notation. It's a really small number. -5 means that this decimal is going to move 5 places in a way that it makes this number really small, which means in this case we'd be moving to the left. So that's going to be 0 point, and it ends up being 4 zeros, and then 9, 7, and then that 6 rounds up to a 7 because after it is a 5. And that's 3 significant figures, because all of those zeros do not count as significant figures. All right, this is pretty much what we're learning about here. We're just wrapping up what we learned. So let's go ahead and continue to practice it. Jim is taking a statistics course. Unfortunately, Jim is not wise. He does not read the textbook. He does not do homework, regularly misses class. Jim is about to take a quiz. He decides to rely on luck to pass this quiz because it is a multiple choice question. There are 10 questions. Each answer, there's only one answer for each of the 4 choice problems, which means it's like your standard multiple choice questions. And he plans to guess on every single one of them, and the probabilities are likely or consistent. What is the probability that Jim gets all of the answers wrong? So we're looking at the probability of getting the answer wrong would be that he has 3 out of those 4 options for it to be incorrect. So that's 3/4, in other words, 0.75. The number of trials in this case is the number of questions that he's going to be guessing on. So that's 10 questions. And we want to know what is the probability that he gets all of his answers wrong. That means that every single question, all 10 of those trials, he got it wrong, which means that our x value is 10. Since it's not talking about at most, it's not talking about at least, we're still using our probability distribution function. So this is your PDF. If it's the probability that x equals a number, in this case that the outcome equals 10 for all of them, right? Then we're just using our PDF version of our calculator. So this is going to be 5a than what we did at the beginning of these notes. So go ahead and tell me what you get. You should have gotten to 3 significant figures. Please remember that that first 0 is not significant, this one after the decimal place, because there isn't an integer on either side of it. So numbers don't start becoming significant until that 5. So 5, 6, 3 would be your 3 significant figures. B, what is the probability that he gets 3 answers correct? Again, it's not saying at most, where it is in C. In B, it's just saying exactly 3 answers correct. So we want to talk about the probability that x equals 3. Our number of trials is 10. Our x value, as we've talked about, is 3. Realize that our P here, our probability changes, because now we're talking about getting the answers correct. So we need to change our probability of success because what we're looking at is flipped. The probability of getting it correct is 1 out of the 4, which is 0.25. Go ahead and plug that into your calculator and tell me what you get. You should have gotten to 3 significant figures, 0.250. I think it ends up being like a 2 after that or something like that, which means that that 0 rounds down. To keep it at 3 significant figures, you keep the 0 at the end. Zeros at the end do count as long as it's after a decimal as a significant figure. Okay, question C. What is the probability that he gets at most 3 answers correct? Which means he could have gotten 0, 1, 2, or 3. We're talking about a range here, a cumulative of this distribution function. And so we're talking about the probability that x is less than or equal to 3. This is how we know that we're going to be using our CDF as opposed to our PDF. So n is still 10. X value is no longer a specific value, it's between, so it has like a lower bound of 0 and goes all the way up to 3. And then our probability of success, we're looking at probability that he gets it correct. So the probability of success is 0.25. Going to our CDF, it pops up like this. N is 10. Probability of success is 0.25. Lower bound is 0. Upper bound is 3. Tell me what you get. You should have gotten 0.77. That 5 has an 8 after it, which means it rounds up to 6. Last problem. To pass the quiz, Jim must have at least 6 answers correct. What is the probability that he passes the quiz? So what is the probability that he gets at least 6? So we could have 6 or 7 or 8. So what's the probability that the outcome is greater than or equal to 6? So n equals 10. Our lower bound is 6. Our upper bound is 10. Probability of success is 0.25, because he needs to get that many correct. Okay, go ahead and plug that into your calculator. 3 significant figures ends up being 0.0197. Again, remember that 0 is not significant. It doesn't become significant until the 1. So that's a pretty low percent chance that if it's a 10 multiple choice questions and you're guessing on every single one, that you would pass the test. These are very short notes because there wasn't really a whole lot more to add. I would recommend either using this time to work on the check for understanding for this section, and you can already start practicing what you know, and you can come to class with questions of what you don't know, or you can see if you want to finish up previous checks for understanding. Definitely don't throw away this time as time that you would set aside to do your notes. Don't throw away this time as a bonus. Use it as a bonus to make sure that you understand material of what's happening in class right now. All right, good job.